This is the second part of the second lecture of week 12. And in this part, I'm going to review some aspects of linear algebra and in fact of systems of linear equation and how we solve the system of linear equations. So first of all, the general form of the system of linear equation you can see here, where a11 and so on, a1yn and so on until a and n are some numbers, and x1, x2 and so on xn are unknown. And on the right hand side here you see b1 and so on bn also are some fixed numbers. And the solution of the system is a tuple of numbers x1, x2 and so on xn, which satisfy this system. And if we have n unknowns and n equations, there are possible three outcomes. So the first outcome can be that solution is unique. The second outcome that there are infinitely many solutions. And the third outcome can be there are no solutions. And there are several methods to solve the equation, the system, but we will now just remind the method of Gauss-Jordan. Let me remind you what is Gauss-Jordan, in fact, elimination algorithm. Let me show you this on this particular example. So first thing what I'm going to do, I'm going to choose one particular equation which is convenient for me to use. So in fact, I choose the equation with the simplest first coefficient. So, and I can do everything with these equations, right? I can multiply the equations by any numbers except 0, and it will not change the equation, right? And also I can divide by any number except 0, and this will not change the solution. So now I want to just choose the first equation to be my main equation, and I rewrite the equation here. And what I do next, I look at second equation and do something to get rid of x1. So here, for example, I must multiply the first equation by -2 and add with the second equation. So my first step is multiply the first equation by -2 and add the second equation. So -2 plus this, we will eliminate x1. -2 times 6 is -12 plus 15, we will get 3x2. -2 times 8, this is -16 plus 19, we'll get again 3x3. -2 times 16 is 32, -32, and plus 38 will get 6. And I do the same thing with the third equation. So I need to find something to eliminate x1. So my next step, to multiply the first equation by -1 and add to this the second equation. The third equation now. So when I multiply by -1 and add to this, I'll eliminate x1. So -1 plus this 0, -1 plus this no coefficients of x2, so I have just -6x2. -8 plus 3 is -5x3, and -16 plus 6 is -10. So after my first step, I eliminate x1 from the second and third equation. So I got a new system where the first equation is the same equation from the original system, and to second equation, in second and third equation we don't have x1 at all. Okay, so next what I'm going to do, I rewrite the first equation I just need to have it. And I rewrite the second equation. And now I need to get rid of x2 in the third equation. So I need to do something to get rid of this x2. So I have to multiply the second equation by -2 to get, just by 2. By 2 to get 6, and add to this the third equation. So when I multiply by 2, I get 6. When I add to this, I eliminate x2. So 0 for x2, and this times 2 is 6, minus 5 is just 1 x3. So 12 minus 10, this is 2. So x3 now 2. So now we get one answer for x3. What we do next, we come back, use this x3 to find x2, then use x3 and x2 to find x1. So from this equation, what do we have? We have that x2 is 6 minus 3 x2 over, x3 over 3. So this is 2 minus x3, and x3 we know is 2, so this is 0. And from the first equation we obtain that x1 is, from the first equation, x1 is 16 minus 8 x3 minus 6 x2 over 2. This is 8 minus 4 x3 minus 3 x2. When we substitute, x3 is 2, so 8 minus 8, and x2 is 0, so we again obtain 0. So the solution of our system is x1 is 0, x2 is 0, and x3 is 2. And if we have such situation, if we have particular numbers for x1, x2, x3, it means that this system has a unique solution. So this is unique solution. Okay, let's see what else we may have when we use this Gauss-Jordan elimination. For example, let's look at this example, and let's do the same method. So the first step, we rewrite the first equation. The second step, we do something to get rid of x1 in the second equation. So what I should suggest, to multiply the first equation by -1 and add to the second. So -2 plus 2 is 0, -2 plus 2 is 0, why it's -2, -4 plus 4 is 0, -1 plus 0 is -1, so minus x3 is, and here -8 plus 6 is -2. And we do the same with the third equation. So to get rid of x1 here, we need to multiply the first equation by 2. So multiply by 2 and add to the third equation. Multiply by 2, add to this 0, multiply by 2, add to this 0, multiply by 2, add to this 3x3, multiply by 2, add to this is 6. So in fact, what do we have now? We eliminated not just x1 but also x2 from the equations, right? So in fact, we now already have that x3 is 2 from any of two equations. This one x3 is 2 and this one x3 is 2. So we need to find x1 and x2. But knowing only x3 and having only the first equation, it's not possible to find precise values of x1 and x2, right? Because what do we know now? That 2x1 plus 4x2 plus x3, which is 2, is 8, or 2x1 plus 4x2 is 6, or we can divide by 2 to make it simpler. This is 3. So we have only the equation which contains x1 and x2, and we cannot solve it. So what we do in this case, we take one of these unknowns to be some s. For example, let's take x2 to be s. And then x1 is 3 minus 2x2. So x1 is 3 minus 2s. So this s is called parameter. So s is parameter. And now you see that as you change s, you change the solution. So it means that this system has infinitely many solutions. So this means that the system has infinitely many solutions. So let's see what else we may have. Another example is this system here. And the first thing, I want to change the order of the equation. So the first equation, the main equation which I choose, will not be the first one. I'm going to choose the third one because it has the coefficient minus 1 in front of x1. So I will easily eliminate x1 from the equations. Now I'm going to use the first one and the third one and the second one, for example. Let's multiply the third equation by 2 and add it with the first one. So third equation multiply by 2 and add the first equation. So in this case we eliminate x1. When we multiply by 2 x2, we get 2x2 plus we have 0 here, so we have 2x2 here. And when we multiply by 2 5, we get 10, then plus x1, so plus 11x3. Multiply by 2 1, minus 1, we have 1. And to get rid of x1 in this equation, we multiply the third equation by minus 3 and add it by minus 3 and add it to the second equation. So minus 3 times minus 1 is 3, plus this we eliminate x1. x2 times minus 3 plus 1 is minus 2. Okay, so minus 3 times 5 is minus 15, plus 4 is minus 11. Minus 3 times 1 is minus 3 plus 1 is minus 2. So we eliminated x1. Next step, we rewrite the first equation and rewrite the second equation. And we need now to get rid of x2 from the third equation. So what we do, we just add third equation and second equation. Then we will get rid of this one. And in fact, when we add, we also will not have x3, right? So we'll have just 0 on the left. And when we add the right-hand side, we'll have minus 1. So we obtain something strange here. 0 is equal to minus 1, which is wrong. This means that the equation has no solutions. So when you get something strange like this, means that the equation has no solutions.